In this video, we're going to cover a very important fundamental in electrochemistry, one of the oldest equation in electrochemistry, which is Nernst equation. It's almost 138 years old. In this equation, the cell potential of the galvanic cell is related to the standard cell potential, as you see in this equation here. E equal E node minus RT divided by NF and ln Q, where Q is the product concentration divided by reactants concentration. E node of the cell is basically the E node of the cathode minus the E node of the anode. R is the universal gas constant. T is the temperature in Kelvin. N is the number of moles of electron transfer in the cell. F is Faraday constant. We can simplify this equation by adding all the constant relationship here. And basically, we end up with the equation that we're going to use to determine the galvanic cell potential, knowing the standard cell potential of the cell. Standard condition, which is the pressure is 1 atmosphere, the temperature is 25 degrees Celsius, and the concentration of the metal ions in solution is equal to 1 molar. E is at any given concentration of the metal ion. So here's a very good example that I have been using in all my short videos on the galvanic cell, which is zinc copper galvanic cell. So as you can see, here's the cell reactions. Copper plus 2 is reacting with zinc solid to produce copper solid and zinc plus 2. So clearly copper plus 2 is taking 2 electrons and zinc solid is losing 2 electrons. So our number of electron transfer is 2. The standard cell potential, which is E node, as we use the table, you will see that copper is going to be the cathode and zinc is going to be the anode. The higher up, the more positive potential is the cathode. The lower down, the less positive or more negative potential is going to be the anode. So if you subtract the cathode minus anode, you're going to end up by having the 1.1 volt. Here is the concentration of the metal ions. Zinc ion is 0.1 molar, copper ion is 0.5 molar. Clearly, we're using Nernst equation to determine the cell potential, as you see here. So plugging all the information that we already have, or basically all what left is just doing the calculations, and our cell potential is going to be 1.12 volt. And this is a standard procedure to determine the cell potential using Nernst equation. This can be applied to any given galvanic cell, as long as you know the cell reaction and you have a balanced cell reaction. It is important to make sure you balance the cell reactions, because the exponent, there is an exponent here you don't see, because we have 1 mole of zinc ion and 1 mole of copper ion, and that's why the exponent is again 1. But if we have different numbers of moles of metal ions, then this will be reflected on the exponent on the metal ion concentrations. Thanks for interacting with my videos. Thanks for watching my videos, and I will see you in the next one.